think we're going. Okay. All right. Same thing as before. We're still identifying points of concurrency. This time we're going to find the circumcenter, the incenter. We're also going to find the orthocenter. Okay, so this is something that we are also going to add. All right. So review. 3 or more lines, rays, or segments that intersect in the same point. Those are your concurrent lines. Where they intersect is your points of concurrency. Based on this picture, lines A, B, and C intersect at point P. So point P is your point of concurrency. All right, circumcenter. The circumcenter is formed by your perpendicular bisectors. And if you recall, when you find the circumcenter, it's the same distance to all of your corners. So PA equals PB, which also equals PC. So all of your red lines here are congruent to each other. The incenter is formed by your angle bisectors. And once you have drawn your angle bisectors and have found the incenter, then the perpendicular distance to each side is equal to each other. So PD is equal to PE, which is equal to PF. The rule for centroids, remember they are formed by our medians, is that the part from the vertex to the centroid, so your BP, it is 2/3 of the entire median. Okay, that was the rule. But we found out when we were solving them, we learned that the bottom piece, so PF, is half the length of the top piece, which is BP. Okay, so the general rule is that the top piece is 2/3 of the whole piece. But we learned that the bottom piece is half of the big piece. Orthocenter is formed by our altitudes. And there's really nothing special about them like there are all the others, other than the fact that they're simply the height of your triangle. So they are perpendicular to the opposite side. So that's the only thing that's no other special property. Okay. All right. So the first thing we're going to do, we are going to find the circumcenter of a triangle. So go ahead and plot your points, draw your triangle. So go ahead and plot your points and draw your triangle. Okay, so once your triangle is drawn and your points are labeled, the first thing you're going to want to do is find the midpoint of all of your sides. So step 1, find midpoint. The cool thing about this triangle is since we have horizontal and vertical pieces, it's easy to find the midpoint when it's horizontal and vertical. It's not so easy, or not that it's not easy, it's not as quick to find the slanted, okay? So find all your midpoints. So AB, well, since it's 1, 2, 3, 4, 5, 6, then the midpoint is going to be halfway. So 1, 2, 3. So there is our first midpoint, and I'm going to call this point D. The midpoint of this one, 1, 2, 3, 4, 5, 6, 7, 8. Since it's 8 units long, the midpoint will be halfway. 1, 2, 3, 4. So I'm going to call that E. Now to find the midpoint of AC. So remember, to find the midpoint, you add both points and divide by 2. So if I add A and C, so -2, -2, 6, 4. So add the 2 points and divide by 2. So 2, 1. So 1, 2, 1. So I'm going to call that point F. So I have all 3 midpoints. Now, the next thing you're going to want to do is find all of your slopes. So step 2, find slopes. Again, the horizontal and the vertical make it easy. Undefined. Horizontal lines, slope is 0. AC, well, the slope, count it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So the slope of AC is to go down 6 and go backwards 8, which is 3/4. Okay, are you ready? Now, once you have found your midpoints, once you have found your slopes, now get your perpendicular slopes. Because if we're looking for the circumcenter, I need perpendicular bisectors. The midpoints take care of the bisector part. So now I need the perpendicular part. So step 3, I need perpendicular slopes. So what's the perpendicular slope to BC? The perpendicular slope, so the perpendicular slope of BC is undefined. The perpendicular slope of AB is 0. The perpendicular slope of AC, flip it 4/3 and opposite sign. So now we have our bisectors, which are our midpoints. We found our slopes so that we could get our perpendicular slopes. Now, the easy thing with these horizontal and vertical lines is that, some different color here. So the best part of having horizontal and vertical lines is to draw the bisectors. You're going to draw horizontal and vertical lines. So go to the midpoint and draw a vertical line. Go to the midpoint and draw a horizontal line. Go to the midpoint and draw a, oh, how do I draw a line from here? Well, in all honesty, it doesn't matter at this point, because do you have 2 bisectors? Do you have 2 perpendicular bisectors being drawn? Yes. Well, then there is where they intersect. What do you notice about where they intersect? It's the midpoint of the hypotenuse. Okay, so here is the catch. The circumcenter is the midpoint of the hypotenuse of a right triangle. So when you see a right triangle, the circumcenter is the midpoint of your hypotenuse. Okay, so let me slide this up. All right, this one is going to take a little bit of time. So we have 3 snack carts. They sell frozen yogurt. They're at points 1, 1, 2, 4, and 6, 0 outside of a city. Each of the 3 carts is the same distance from the frozen yogurt distributor. Find the location of the distributor. Well, if I'm at each corner, no matter which corner I'm at, it's the same distance to the distributor. So that means you're looking for the circumcenter, because the circumcenter is the one that's the same distance to all the corners. So you're looking for your circumcenter. So if it doesn't tell you what it's looking for, you have to understand what it's looking for, which means I'm going to have to draw perpendicular bisectors. So plot your points. I drew my X and Y axis on the edge because since all my points are positive, I don't need the other quadrants. So plot your points and draw your triangle. And I'm going to get these labeled. So A, B, and C. All right. Since nothing is horizontal and nothing is vertical, then I'm going to need to find the midpoints and the slopes. Now, you can just choose 2 sides. You don't have to do all 3 of them. So if I choose I'm going to choose to find AB and BC. So I'm going to find the midpoint and the slope of AB and BC. So number one, I'm going to find the midpoints. So the midpoints, so AB, so I'm going to add A and B together. So 1, 1, 2, 4. So that's 3, 5. Divide by 2. So that's 1.5, 2.5. So there's the midpoint of AB. I'm going to do the other side in a different color. So now I'm going to find the midpoint of BC. So BC is 2, 4, and 6, 0. So add those two together. That's 8, 4. Take half. So that's 4, 2. So there are my midpoints. The next thing, I'm going to find my slopes. So the slope of AB, so rise 1, 2, 3, run 1. The slope of BC, 1, 2, 3, 4. 1, 2, 3, 4. So it's rise 4, go backwards 4, so it's -1. So those are my two slopes. So next, I want to find the perpendicular slopes. So what is the perpendicular slope? Well, if my slope is 3 over 1, the perpendicular slope is -1/3. If my slope is -1, then my perpendicular slope is 1. So now I have a point and a slope. So I can do point slope and get the equation of that perpendicular bisector. So let me scroll up a little bit. All right. So y minus y1 equals m times x minus x1. So y minus 2.5 is -1/3 x plus, so 1.5 times 1 divided by 3, so 0.5. So plus 0.5. So I'm going to add 2.5 to both sides. And I get my first perpendicular bisector. So first perpendicular bisector is -1/3 x plus 3. Down 1, 1, 2, 3. Down 1, 1, 2, 3. So if I were to draw my perpendicular bisector through here, that is the perpendicular bisector of AB. I have to go through the midpoint, and I have to be perpendicular. So now I'm going to do it one more time with the other side. So 4, 2, so 1, 2, 3, 4, 1, 2. So here's the midpoint of BC. Now I need a perpendicular line that goes through that. So I'm going to do the same thing again, this time with this slope and this point. So y minus 2, 1 times, that's not equal, x minus 4. Y minus 2, x minus 4. So I'm going to add 2 to both sides. So y is x minus 2. So there's my second perpendicular bisector. So from here, I'm going to use the slope rise 1, run 1. So rise, run, rise, run, rise, run, and then I can draw my line. And I get my intersection, which is my circumcenter. But what I notice is that circumcenter It's not on any of my crosshairs on my grid, so I don't know the exact answer. So when I'm doing my assignment and I have to get an exact answer, I'm not going to be able to get the exact answer by just looking at it on a grid, which is why we have our Y1 and our Y2 so that I can put it in the calculator and get the point of intersection. Okay. All right, so when you put these two into Y equals, and you do second, you graph them, and then do second trace 5, enter, 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 you get that your point of concurrency, your circumcenter, is located at 3.75 and 1.75. So that's exactly where it's located. Obviously, in your assignment, when you're entering your answers, you're probably going to need to enter them as fractions. Don't enter them as decimals. They're going to want them as fractions. All right. So the next three, go ahead and put your X and Y axis where they go. Plot your points. Draw your triangles. Just get them all done. That way it's faster when we're going through all the stuff. So 3, 6, this is point X, 3, 0, this is Y, this is Z, this is L, M, N. Make sure you're always labeling your points. Point P, Q, and R. All right, so once you have all your points plotted, your triangles drawn, all that good stuff, this time we're looking for the orthocenter. Okay, the orthocenter is created by drawing our altitudes. Altitudes are simply perpendicular from the vertex. So since you already know all your vertex, if I have to write an equation, then you're going to use the vertex as your point. If I want the perpendicular, or not the perpendicular, I want the altitude to be perpendicular to this side, then I need this slope so I can get the perpendicular slope. But what's really, really cool in this first picture is it's a right triangle. So just like the right triangle with the circumcenter, it's on the hypotenuse. The orthocenter of a right triangle is the right angle. There's absolutely no work to be done. When you see a right triangle and they're asking you for the orthocenter, it is the location where the right angle is at. So my orthocenter is 3, 0. So that means it is on my triangle. Because it says to tell whether it's inside, on, or outside. So if it's on, that means it's a right triangle. If it's inside the triangle, it's going to be an acute triangle. And if it's outside the triangle, it's going to be an obtuse triangle. Okay, so we have a right triangle here. We don't know what these two are yet because I don't know their slopes. It's easy to determine if it's a right triangle when your sides are perpendicular, and you know that because they're horizontal and vertical. But over here, since these two are slanted, I have to find their slopes so that I can determine if they're perpendicular or not. If you don't want to find their slopes, then you're going to have to do the extra only to find out you didn't have to. So the first thing you're going to want to do when it's not obvious like the first triangle is find the slopes of your sides to see if anything is perpendicular. Because if it is, then you don't have to do any work because you know, oh, it's a right triangle. So this one, the bottom, obviously the slope is 0. All horizontal lines have a slope of 0. There's no question to ask. LM, so I'm going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5 over 5 gives me a slope of 1. MN, 1, 2, 3, 4, 5. Backwards, 1, 2, 3, 4, 5. So that's 5 over -5, which gives me a slope of -1. Well, since 1 and -1 are opposites, then I know the right angle is right here, which means my orthocenter is 1, 1. So it's on because it's a right triangle. So by looking at this triangle, I know it's acute because there are no obtuse angles when it's drawn on a grid. So I know my orthocenter is going to be inside. I just got to figure out where. So the first thing I'm going to do is I'm going to go ahead and find the slopes just to make sure there's nothing perpendicular. So 1, 2, 3, 4, 5, 1, 2, 3. So the slope of this side is 5 over 3. This one is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the slope of this one is -1. So now I have the point that's opposite, agreed? And I have a slope. Well, the perpendicular slope is going to be 1. So since I have a point and a slope, I can do point slope to get my altitude. I have to have 2 altitudes so I can see where they intersect. So the first one, so y minus, so point P is -5, -1. So minus -1 is 1 times x minus -5. Y plus 1, x plus 5, subtract 1. So my first orthocenter, sorry, my first altitude is x plus 4. So if I go here and I just use my slope, rise 1, run 1, rise, run, rise, run, I can do as many as I want to get a good line. So if I were to draw the altitude through there, that would be my altitude. Now I can choose the other one. I'm going to choose to find the altitude from point Q because I know it's going to be a straight vertical line because this one's horizontal. So I'm just going to go ahead and draw the other altitude through there. So I know the equation of this line, the vertical one, bucks, hoy, remember bucks, x equals, and it's going through point Q at -2. So there are my 2 equations of my altitudes. In this particular picture, it's easy. I can see where it intersects because it did intersect in the crosshairs. So I know that the orthocenter is located at -2, 2. If I did not see that, then I would simply plug in -2 into this formula down here. So y equals -2 plus 4, because since x is -2, I get that y is 2. So again, my point, -2, 2. All right, last part is finding the centroid. Please make sure when you're doing your assignment that you're reading whether they're wanting the orthocenter, the circumcenter, or the centroid, so that you do what's correct, okay? So if, I want y'all to think about this. Remember the centroid, it's the center mass. It's your center of gravity. So if you have a triangle and you want to balance it on your pencil tip, if you find the centroid, you can place it on top of your pencil tip and it will balance. Yes. Now, if it's in the slap dab center of my triangle, what other kind of point is slap dab in the middle of something? A midpoint. A midpoint is slap dab in the middle of 2 points, right? Are you with me? Okay. So if a midpoint is slap dab in the middle of 2 points and a centroid is slap dab in the middle of 3, do you see a pattern? So to find the midpoint, we add 2 points and divide by 2, right? So to find the centroid, you're going to add 3 points and divide by 3. And that's all you're going to have to do. So you take your 3 points, so -2, -1, 1, 8, and 4, -1. Add them together. 4 plus 1 is 5. 5 minus 2 is 3. 8 minus 2 is 6. Now divide by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. There is your centroid. I'm going to call it T. Wow. That's all you got to do. And if it makes sense, if the midpoint is the middle of 2 things and the centroid is the middle of 3, then you would do it the same way. So this is negative 9. 8 minus 2 is 6, divided by 3. Negative 9 divided by 3 is negative 3. 6 divided by 3 is still 2. Eight plus 8 is 16. 16 plus 20 is 36. 7 plus 5 is 12. 12 plus 3 is 15. Divide by 3. 12, 5. And that is how you find a centroid.